Hello, everyone. My name is Colin Falwell, and I'm the Director of Observability Strategy here at Sumo Logic. Today's topic is going to be around observability driven by design. We're going to talk about the myriad of challenges across the IT landscape if organizations don't adopt a observability driven by design first approach, especially when building modern applications that provide flexibility and portability. So in this session, we're going to explore some of the principles and underlying use cases around adopting open source tool chains, shifting left the activities that are required for observability, and empowering digital transformation through value stream management. Now, my greatest strength has always been in my ability to break down complex systems through this process of reverse engineering. And throughout my career, providing leadership in enterprise and solution architecture, performance engineering, IT service, and operations management, I've had to communicate those complexities to teams that are working on transforming the business. And I've learned that it makes it easy if I break that complexity down really into three pillars, consisting of a framework, guiding principles, and a roadmap. The framework really serves as a reference point, a way to identify where we are, where we've been, and where we're going. Whereas the principles, much like a constitution, really ensure that teams adhere to a common set of truths, which policy and processes are evaluated. While the roadmap really provides the direction and the instructions for building a successful program. So today, we're going to cover at a very high level my framework and the inputs that define the basis for building the principles of observability. We'll also touch on a couple of ideas for the roadmap before we wrap up. At the end of this presentation, if you really like what you hear, I'd encourage you to reach out to your account team here at Sumo. Let them know that you're interested in implementing an observability by design strategy. And in doing so, we'll bring together a dedicated team that can come in and custom tailor a strategy for you. So let's get started. I like to start by asking a fundamental question. What is observability? And I mean, really fundamentally, what are we talking about? Suppose that we could answer this and apply it holistically to an organization. Would we see fewer companies struggle to achieve speed, agility, and innovation? Would we see a decline in the number of companies failing to achieve reliability? So think for a moment about some of the following complex systems: an assembly line, a modern electric car with self-driving capability that comes off that assembly line, the space shuttle, a commercial airliner. What do all these complex systems have in common? Yes, they're observable, but what is it that makes them observable? How are they made to be the observable systems that they are today? Were these systems designed just to be observable to the engineers that made them, or to just the operators that operate them? Yes, in some respects, that may have been the case, and in the past, true, but not today. Today's systems are interconnected, they're interoperable, they're growing in complexity at an exponential rate. Companies rely on this real-time telemetry to protect their brand and increase revenue, which means that observability must be a company-wide mandate and not just a DevOps program. Observability is often discussed in terms of the requirements to collect logs, metrics, and traces. And we think these types of data are essential to enabling developers and operators in the companies to understand their systems. But stop for a moment and think, do you think that the space shuttle would have been as successful a platform for building the International Space Station, or commercial aviation would be as reliable in industry today if they just collected logs, metrics, and traces? What if these platforms use different tools or different vendors that didn't interoperate with one another? Or worse, different teams within these organizations that built these all use different tools. It's clear then that simply collecting lots of varied data isn't a solution. If observability is the recipe for reliable systems, why do we have such a problem in achieving reliability in our commercial applications today? Perhaps the problem is that we're not doing a good enough job in defining the problem we're trying to solve in the first place. Now, Wikipedia defines observability as a measure of how well the state of an internal system can be inferred by the knowledge of its external outputs. This is the definition of observability. And while it does a good job of defining it, what it fails to do is it fails to give us the framework that we need to understand how to go about deploying and developing observable systems. Now, I've spent a great deal of time with companies and enterprises that are both successful, as well as those that struggle to stay competitive and relevant in today's intelligence and software-driven economy. I've spent a lot of time thinking about what makes them successful or not so much. And one thing is certain, modern observability is fundamentally reshaping and transforming how companies do business through digital transformation. So digital transformation must be grounded and rooted in the successful application of modern observability, but how and why? Well, it is. It's rooted in this notion of intelligence and flow. It's about time to build our framework, but before we do that, I want to spend a few minutes and just talk about intelligence. Kevin Kelly, the author of The Myth of a Superhuman AI, eloquently denotes that intelligence is a combinatory continuum. I'm going to give you a second to think about what you think that means. Took me a while. Essentially, he's arguing that multiple nodes, each node in a continuum, create complexities of high diversity and high dimension. Another way of stating this would be that intelligence is a horizontal attribute of a system, not vertical. You can't scale it up, you have to scale it out. If that's still somewhat confusing, let's break this down into something that relates a little bit better to modern systems analytic processing. Intelligence in a system depends on each node. Let's call that an entity. Having the capability to create high diversity complexes, let's call that correlations, in high dimensions. Let's say that's cardinality. In other words, to have a shot at achieving robust machine learning and artificial or even augmented intelligence, you at least need a highly scalable system with flexible, unified entity model that can maintain complexity and correlations across a lot of different dimensions of high cardinality data. Suppose that your data and information domains are siloed. In that case, your algorithms are unable to establish high diversity. Your dimensionality is going to be low. The intelligent systems that you're trying to build with robust control planes that give you the reliability and automation are always going to be a little bit out of reach, never entirely what you wish they could be. Now, I say this with a caveat. The more realistic version of artificial intelligence is what we've already been dealing with. It's some form of augmented, not so much artificial intelligence that really helps humans with specific tasks, not some kind of general omniscient godlike entity that is good at everything, though I would love if our platform could do that today. But some tasks that humans do will indeed be replaced by machines. But in the general scheme of things, humans and machines have to work together to solve tough problems. And that's what we're doing here at Sumo. You see, we see this evolution in the concept of observability, modern software architecture, containers orchestration, and the ephemeral nature of things, from Lambda functions to short-lived containers spanning multiple clouds and around the globe, are challenging to understand over time. And that's the key, you see. An entity's state can change, it can fluctuate, it can evolve over hundreds to tens of thousands of times over the course of any given time series. This highly ephemeral nature of today's compute challenges legacy and proprietary tool chains. They just can't keep up. Trying to build intelligent systems that can track the functioning of these entities over time poses an enormous challenge, and it's downright impossible to do without a unified approach. So, what do we have to do? We see this convergence starting to take place. And if I've done a good job, hopefully I shouldn't have to ask or explain any further why it's important to have a centralized platform or a single pane of visibility, or why existing tools fail, or why it's so important for critical multi-cloud or hybrid cloud to have this unification or this convergence. But we see this convergence taking place. We know that customer experience, the company's experience via critical apps, and the performance of security posture are top of mind. That it's all about consistent and reliable behavior of these systems over time. However, many of our customers are still siloed, and they say that on the whole, their current solutions just don't deliver on the promise of improving reliability or improving their monitoring, troubleshooting, or being able to secure their applications better. Converge the silos. Leave behind the traditional tools that don't scale, or the modern tooling that still is leveraging proprietary agents, because they lack the interoperability and portability. And your organizations will start to realize the value that an open standards, interoperable, and unified platform can provide. The ephemeral nature combined with high cardinality across logs, metrics, traces, and spans create complexity that very few platforms are designed to handle. This convergence into a single observability platform that brings together all domains, including security, is what we've developed here at Sumo Logic. Most tools just process a fixed set of metadata because they're not designed to scale. They can't bring in all of the raw data. We've learned how to not compromise in that area, to store and preserve the raw data at scale, to retain the richness that exists. Having done so, we've really begun to harness the power of data through groundbreaking machine learning, such as global intelligence, and our new alert response capabilities that are currently in beta. We've brought an industry first in tracing, span analytics, by storing trace data as logs so that you can query spans and leverage our advanced language as you would any other log source. The more commodity and machine data types and data sets that you actually send us, the smarter the platform becomes for you. The intrinsic value of your data actually goes up. Yet we find a lot of organizations are reluctant to consolidate, not because of cost. In fact, cost reduction is significant with improved cloud economics at play, like our data tiering. But the truth is, I think people are just naturally resistant to change, even when that change leads to an advancement in, say, operations intelligence. So the question then becomes, how do we address the resistance organizations face in undertaking tool consolidation? What do we have to do? I think we have to do a better job of explaining the value of an observable enterprise. We need to leverage a framework as a tool to promote the benefits that await everyone across the organization if we want to succeed in promoting change. So the moment that you've been waiting for, let's jump into this and let's talk about this framework for observability. The framework I have is broken up into 4 observability domains, and it represents the value streams of the organization as it flows through IT. If you think about it, the first 2 domains, DevOps, monitoring, root cause, and SRE, are all about app infra and cloud architecture. But as you move to the right in the organization, as you get into business intelligence, IT service, and operations management, the data becomes more about the data and information architecture itself. And as you continue to go to the right, now you're really focused on the business architecture. And within each of these domains, there's been this evolution or this level of maturity, of process maturity that takes place naturally through time. DevOps teams operations started out just keeping the lights on and providing infrastructure. And as they got more advanced and DevOps started to consolidate and developers and operations really started to merge together, it's now monitoring and managing change and incidents and capacity and customer experience, leading postmortems and doing more things like infrastructure as code and automation. Within the risk, SRE, and governance, it all started about just how do we understand the telemetry that's coming through? Let's try to improve reliability. We optimize processes through automation. We're improving signal quality. And we have these statistical models like capability of process and service level indicators and objectives. And that drives compliance and standards. And then you start to converge business intelligence and ops intelligence, protecting brand and revenue as you go along. And you become an innovation governor to the organization. If things start to get unstable and your capability of process starts to fall, your error budgets are draining much quicker than you would expect them to, you have to slow the rate of change in the organization and switch over into a period of stabilization so that you can speed up again. Within the business intelligence, IT service, and ops, it's all about eliminating data silos, ensuring that you've got high quality of data, that you can visualize the broader business processes to the organization. Cost to serve, workload optimization. These are the things that are important to business intelligence teams. And within the digital enterprise, and really kind of looking forward to the future, it's all about bringing all of this data together, and artificial intelligence, or augmented intelligence, if you will, and machine learning driving asset intelligence and design intelligence, observability, dependency recognition, structural analysis, really helping businesses understand the external factors that might be affecting the enterprise and how to shift and course correct through all of that, really leading to that next generation of wide scope AI ops, as Gartner refers to it. Now, within all of this, it's important to understand the value streams of what's taking place here, because on the left, all of this information, this machine scale commodity data, it's very generic. There's not a whole lot of intelligence in that data. It has to be enriched, it has to be processed, it has to be correlated. It has to be put through its paces in terms of that cardinality, being able to tie all the stuff together. And as you do that, the value of that data increases to the organization. It becomes very specific. Becomes incorporated with the other business insights and business intelligence data in the organization. So it becomes very specific to the DNA of the organization. In the digital enterprise, that initiative to become digitally transformed, to improve the outlook and operation of the business is what drives that transformation and budget. It drives the requirements and standards through IT service and operations teams into the risk and governance categories, all the way down into DevOps, making sure that that adoption is adhered to. This is the framework. So I'd encourage you, in terms of the framework, to think about where would you place the dot in I am here right now. You know where you've been, you know what the future looks like and where you're going. Where would you place yourself today? And once we have a good fix on the framework and we understand kind of where we are on the overall map of things, we can turn our attention to some of the principles. Before we do that, I just want to leave you with this one last parting thought. In terms of convergence, if you think about it, what would happen in the organization if you were to bring that convergence and shift that left into the DevOps monitoring and root cause? What if you were able to collapse all of your tools, embrace open standards, provide a vendor agnostic, scalable, interoperable observability solution or platform? When you do that, you're going to unlock the potential. You're going to bring the value of that data and increase it on the left so that it gives you even more value across the organization. Great. Now we know that. Let's talk about the principles. When it comes to the principles, we've already talked about some of these. Control theory. We've talked a little bit about capability of process. I think we just touched upon just a little bit about data quality. But I want to leave you with something here that's really important to understand. And that control theory really, as we said, is dealing with the control of dynamical systems and engineering processes. The objective here is to develop a model for controlling these systems through control action or automation. Capability of process is a core Six Sigma statistic. It was developed actually for measuring quality control and industrial automation. In modern software, CP is the process of really kind of defining the lower and upper specification limits for both leading metrics or health metrics or lagging success metrics. Modern SRE, in fact, is rooted in maintaining a high degree of capability of process, where CP can be leveraged as that statistical lens to really identify areas of weakness or churn, highlighting where and when investment in automation can be the most effective. CP can be applied to anything: code quality, engineering efficiency, operations, security, even business metrics. It should be the de facto process that we use to ensure that we have successfully achieved our third principle, which is really data quality. And as with anything, a successful strategy in observability is dependent on the quality of data that you create. If we produce garbage, achieving reliability is increasing left up to good fortune. The greater our data quality, the better our AI and ML will perform, which in turn will allow us to create more robust automation and control. To summarize this up nicely, control theory is about creating models that define the reference variables we intend to measure as an output aimed at control. Capability of process is about measuring statistically the variability of those outputs against the proposed specifications or acceptable tolerance defined in the model. And data quality ensures that we think through how we generate the data that we use in those models to create highly reliable control input. Now, by applying these principles in the development and creation of value streams, they're going to provide a robust frame of reference to succeed in creating repeatable processes of observability-driven development. Fantastic. Now, let's talk just a few minutes about the roadmap. When it comes to the roadmap, there are a few ways that we can go about it. Typically, what we'll do is we'll start with an inbound value stream analysis. This is where we look at all of the segments in the organization around which value stream is designed. We look at the personas. We find out what's important. What do you need answers to? If what are you having trouble or struggling with getting answers to today? We codify that. We bake that into a declarative code base that codifies observability and the SRE governance. We can visualize systems and solution architecture. We can control the data assets and analytics. We can build in the personas and the KPIs and dashboards. We know what signals need to go to what personas across the organization. It really makes it easy to put all of this in and to walk through these processes, because this really builds the roadmap of where you are today and what you need to do from a very tactical standpoint. What's important to the business in terms of reporting requirements. Another approach that you can take is around lean process value maps, or value stream or flow state. We already have a solution out of the box called software development optimization. It takes you through all the DORA metrics from code commit all the way through the development process into production. But what if you were to extend that to encompass everything upstream from that code commit process? If you have an experiment, you're defining a hypothesis. How many experiments can you run across teams over the course of a year? How many times do you get to analyze these ideas? How long does it take to acquire resources and funding and allocate those resources? With an analytics platform like Sumo Logic, it makes it very easy from a standpoint of bringing in logs to bringing in lookup tables, bringing data in from other systems, to tie all of that stuff together and provide a dashboard that gives you that holistic end-to-end view of your business processes. So, just to take away, observability driven by design. You need to take a holistic approach. You need to lead with data and information architecture. It's not enough to be a bottoms up. You really need to have a holistic view here, to unify logs, metrics, traces, and events, and all of this other data around a flexible entity schema and a common analytics platform that can give you insight across high complex correlations and high diversity and cardinality. You need to perform VSM or the flow analysis and map signals to the personas that need data across the organization. Declare that as code. Move forward with something like Safe Agile or Agile Release Chains or something similar to speed your time through the pipeline. Shift left all those activities that are required for security development, business intelligence, to the earliest stages of the product development lifecycle. Build in the signals from every system that are required to really derive visibility into process and operational intelligence. And lastly, embrace open standards. Vendor neutrality is really the path forward. If you're still using proprietary agents or legacy technology, you're not going to have the freedom to go with the most robust analytics solution on the back end. And you're not going to have the uptime that you can expect from a modern system around the inherent uncertainty of some of the legacy systems that have been built and kind of made to operate in the cloud. I hope you've enjoyed this talk. I hope that you've taken something away. I just want to leave you with these three things. Observability-driven development is the key to digital transformation. Through that, you get increased reliability, innovation, and time to market. You get improved developer efficiency or DevOps efficiency and a decrease in churn, because your resources are spending less time and doing swivel chair and all of these other things trying to establish reliability. They have more time to innovate. And this convergence of DevSecOps and moving this all to the left is a way to really increase the value of your data in the organization. Thank you. I really hope you enjoyed the talk today. My name is Colin Falwell, Director of Observability Strategy. And if you'd like to learn more, please reach out to your account team and book some time for us to come and talk to you further about observability driven by design. Thank you.